Like terms are terms that consist of the same variables raised to the same powers. For example, in this first blue bubble, we have 10x cubed, negative 4x cubed, and 3x cubed. They are like terms, because they have the same variable x and are raised to the same power of 3. In this red bubble, we have terms, and they are like terms because they all don't have any variables and aren't raised to the same any powers, so they are like terms. In this red bubble, we have they are like terms because, again, they have the same variables y and c, and the same variable y is raised to the second power in each term. The same goes for this blue bubble, for x, 2x, and negative x. Variable x raised to the same power. Adding and subtracting like terms. If we have the algebraic expression 4x squared plus 3b minus x squared plus 6b, we can add and subtract the like terms, which would be 4x squared and negative x squared and 3b and 6b, and this is called combining them. So, if we add 4x squared, or rather subtract this x squared from 4x squared, we have combined those two like terms and simplified it to equal 3x squared. We can then add and simplify the like terms 3b and 6b. And 3b plus 6b, we are combining those two like terms by adding them, and we end up with 9b. And we have simplified this algebraic expression by combining like terms using addition and subtraction. Multiplying and dividing like terms. Multiplying and dividing like terms is different from adding and subtracting in that you can multiply a term, for example 3n, by a term with a different exponent or variable. In this example, we're just using the same variable. So, the first step would be to use distributive property to multiply 3n by n squared and 4n. So, we do that. It looks like 3n times n squared plus 3n times 4n. And then what this looks like when we multiply it out is 3n cubed plus 12n squared. And then, because these two terms are not like terms, we cannot add them, even though we multiplied these different terms. How it ends up going from 3n times n squared to 3n cubed is simple and easier to see if we write it all out. So if we have 3n times n squared, it's the same as 3 times n times n times n. Now that that is written all out, we can clearly simplify this and write it as 3n cubed. The same goes for 3n times 4n. If we wrote it all out, it would be 3 times n times 4 times n. And if we simplify this, we can now more easily see that 3 times 4 is 12, and n times n is n squared, so it would equal 12n squared. Now, dividing like terms. Hold on while I erase this. Okay, so if we have 4n squared divided by n, the principle is very similar to multiplying. It's easier to see if we write it all out. So 4n squared is the same as 4 times n over n. And then, so now we can cancel these variables out. N over n is the same. And now we've canceled this and this. Simplified, it equals 4n. To summarize, when multiplying and dividing terms, you can multiply different terms regardless of what variable or what exponent they are raised to, which is unlike when you are adding and subtracting like terms.